Hello everyone, I'm Young First. Welcome to my channel. This is a series about a self-mock technical interview. Today we will solve the daily problem in LeetCode. So let's start. Find the problem. The difficulty is hard, so I think we should resolve this within 30 minutes in interview. Generally, interview has about 45 minutes. Besides the self-introduction or some routine conversation for your algorithm test, it is about just 30 minutes at most. So let's start. Let's read the description. It's a hard and service. With respect of a given puzzle string, a word is valid if both the following conditions are satisfied. Word contains the first letter of puzzle. For each letter in word, that letter is in puzzle. For example, if a puzzle is A, B, C, D, F, G, then valid is F, A, C, D, C, A, B, B, A, G, B, C, E. So the invalid word is yes, this is not include A or S. Okay. There is two conditions. One is the word contains the first letter of puzzle. For example, A has to be included in word, and each letter in word it is in puzzle. So the condition is very clearly, and we need to return an array answer where answers is the number of words in the given word list of words that is valid. The puzzles I. Okay, so there is two arrays and the array length is very large. Yes. Lower English case. So what should we do? First, we should think about the brute force solution, and then we optimize the brute force solution to an accessible solution. So if we are given a word and a puzzle, we can check that it is satisfied, it is valid in word in the length of word multiply the puzzle length, because we can iterate the puzzle and put every character inside a set, and we check every character in word and check that every letter in word that is in our set, and for the first letter we just check that when we return the character in word. So so it's very simple, but the word length and the puzzle's length is very large, so we can't do that because with the brute force solution we have the words length multiply the puzzle's length and multiply the every word's length is 40, is 50, and multiply the length of puzzle, so we will get a TLE definitely. So we need to optimize that. So we need to return the number of words in the given word list words that is valid with respect of the puzzle. We have two optimization direction. First is we pre-process the answer, but we process the words, and then we iterate every puzzles to and get the answers. Another direction is we pre-process the puzzles, and then we iterate the words. So it's a two direction because the words length is larger than puzzles. So I think we should pre-process words first. Let's try that. I may be wrong, but I want to try this direction first. In this situation, words okay. First, we need to we can divide it's the first condition. According to the first condition, we can divide the words into 36 parts, and for each part, we have the words that this character appears in this part. For example, word we have array that called words by character, and this is a list for and every index is a length of 26, and every index presents a character. We for each puzzle we just need to find the words in set that index. And in each index, we need to guarantee every word. We need to guarantee the second condition. Each letter in word is in the puzzle. How to do that? Okay. Okay. If we present every word from A to Z, and present use integer to present whether it appears. We have after the square of 2, the power of 2, the power 26 of 2. So it's very large. So we can do that. Kind of large. So we need another solution instead of the bit mask. Yes. I have no idea. Maybe we need to try to pre-process puzzle first. So how can we do that? In fact, maybe we can use the bit mask, but plus the try. For example, we can for every bits we present the whether this character is in the answer, and we don't present it in integer instead of the try. So the try is very large, and at most the power 26 of 2 two node, so it is it's very large. It is not accessible, but in many okay, this is at worst case, but because the word's length is the power 5 of 10, so in worst case, it's not this, it's instead of it's the power of 10 multiply the 26. Yeah, it's in the worst case, and when we iterate the puzzles, and we need to travel the try and until the end. Because the length is 7, so the time capacity to travel the try is this, and multiply 26. Yeah, that's it. I think I get the answer, and the total capacity is this. It's the time capacity to construct the try, and plus the puzzles length is the power 4 of 10, and multiply this. I think this one is accessible. Okay, it's not a little bit large. So okay, there. This is not the multiply solution. Multiply relationship with the plus relationship, because this is the enumerator whether every character is appears, and this is the depth of the try. So this is the final capacity. Let's do that. Okay, this one is accessible, so let's do that. Okay, I get my solution. I will explain this once again to you, because before, although I'm very clarify my solution in my brain, but because this one is very difficult, and I just think of it after some trying. So I will explain my solution again. First, because the brute force is will get the time limit exist. So we need to optimization solution and the optimization direction is pre-process words, and we divided it into according to the first conditions, we divided into 26 parts. For each parts, we use try to present the the character, whether it appears in the character, and after process of words, we iterate the puzzles. For each puzzle, we can search the try and find the total answer. This is the final time complexity, and the space complexity is the space complexity is the try, and the try is this. This is time complexity. This is the space complexity. So let's implement our code. First, first step, we need to pre-process words, and then iterate the puzzle and construct the answers. Oops. Okay, and then we return answer. Okay, so I define some helpful variable. This is the length of puzzle, and n is the length of words, and the answer length is p, and we need to return that. Okay, so for each word, we need to convert it into a set. And for each iterator of set, we have this. We need to construct put the word in the try, and I think there put word, and how we need to is for try in range A and A to Z. Can we do this directly? I'm not sure. And this is a root, try root. Okay. So we need a try node definition. Let's do that. We have a variable which is the children, which has two which a tuple, and it's the children present that present not appears and appears. We use 0 to present not appears and 1 to present appears. And we have a count, which counts the words number inside this tree node. Let's do that. We need a push function. We need a push function. This is a word, and maybe we use a function instead of class method to do that. Push self. Okay, we have the word, and we have the word index, and we have the current node, and if we are set, we iterate down or iteration down to the word, it's return. Else, if and I think this is a site instead of the site. It's 26. We need a return, and else, so we are looking to the picture of a plus 1, and if find is in ice, we push note children. Yes, it's in our set, and it's still s, and it's +1. Else we need to push it to 0. Yes, when we do that, we need to update node count, and because this one is possible now, so we need to unlock that. Yes, we need a list to modify by children, and if it's 0 is none, we need to unlock that too. Okay, to push W. This is S, and this is the 0. Now we need to iterate. We need to search. We have we have the first character, and guarantee every words appears, every letter in words appears in puzzle. We can use a set too. And here yes, here let's define the search. We have a set, which is our puzzle, and we have a tree node. Yes, and we need to help index like this to identify which character we are looking for, and sounds, and here we need an answer too, and if the current letter is if I is greater 0, the current letter is that. If it in X, we need to return search. Search node node 10 children second one and s and plus 1 plus we need to search the 0 because we need to guarantee that each letter in word it is in puzzle. If letter in puzzle disappear in word, so we don't care. So that's that. And else we need to return this one. We can only choose that. And if we need to check the node is validate, so if it's not, we need to return 0. And when it's 26, we need to return the value instead of. So I think that's it. Let's run the code. Okay, it's stuck. I need to check that. This is a dictionary, I think, and it's I and here. Let's read our code continually to find the bug. Maybe it'll push that. Okay, I think every line code is fine. Yeah, this definition is useless. Let's delete that. And stuck. Then maybe we can refresh the page. The network is very slow. Just be patient. It has been for 40 minutes. Stream okay. I guess so. In range 26, and here is ORD. Char ORD A plus I. Okay, set cannot be interrupt and okay, so there is no range. Count. Try node. Has no attribute count. I think this is count, right? Oh. Something is wrong. Okay, solution objects try node object has no attribute count, but this one is count, right? Maybe we need to yes, we need that. Value. Okay, this one is count. Sadly, it's the wrong answer. It's very difficult problem. I think I need an hour maybe. Let's debug the problem. I think let's use small examples, and we push print s and I think. Let's run that. AS is expect. maybe we change that to z, and we print 1. We print 0 here. It's 1 until 1. Yes, this is as expected. Okay, I need to check that. Here, print is 45, so the end is 45. Okay, this one is expect to be 35, and no, it's 36. Yeah, but we need to pass the count before we return. Okay, let's run the examples. This bug is caused by my mistake. We still need to add count to 1 when we get the 26, the last one. So I think it's offset. Let's try to submit. Okay, time limit exists. What a sad story. There is something wrong. Maybe my code, maybe my algorithm. The time quantity is accessible, I think. We do need a count plus 1 here. And this doesn't contain repeated characters. Okay. Okay, let's revert the change. We still need the count +1, so that we don't. Okay. We don't need to search until the end. Maybe okay. We found something wrong. Let's check the time complexity. Okay. I think this one is not right. In worst case, because we have a iterator here. This is 26, and the push stack, the depth of push stack is 26 too. Okay. Okay, I think we don't need this. We don't need to depart it into 6 parts. Just and in this situation, we need to pass the first the director, which means we have to find this one, and in search in here in search we have to we have to have this one if the current letter is equal to have to. We need to return we need to return this one. And else Yes, exactly. Let's run the code again. In this situation, the time quantity is right. We can delete this 26. And the matter is right too, I think. Okay, Mr. Okay. We need to pass the have to in our search. Okay. It's virus only 2. Maybe it's we need to refresh the page. Oh, it's stuck again. Hopes. Okay. Let's run our. Okay, here. Run our big examples. In fact, I did this about 2 years ago. Yeah, it is accept just once. Okay, I get the accept. So let me submit my solution. Good luck this time. Okay. Thank you. Thank the God. It's almost 1 hours to implement and to debug. I met some issue to write the run return condition, and I analyze the time complexity wrongly first time, and I fixed it after I get a TLE here, and update my search function according to my new change to my try. So I think this is today's video. Thank you very much. Thank you for my on our videos. It's so glad to be with you together. So bye bye. See you tomorrow.